Hello learners, I'm sure your studies must be going on now just a few days before the exams. So today I'm back with another very important chapter of book 1 known as integration. I'm your mathematics guru Shivani ma'am, and this particular chapter is, you can say, sometimes a nightmare of most of the students. So they always feel integration is the most difficult part. I'm not denying the fact, definitely it is difficult, but it's not like that you can't do it. If you learn it in a proper manner, integration can be easily mastered. So here in this book, we are having 4 different chapters or integration. So you can say that half of the portion is the other chapters and half of the portion for this book is integration. And therefore, the mark valuation is also very high for this chapter. So it's divided into first part where we are doing the basics integration. Second, we are going to go with the special kind of this, that is definite integral, then applications of integration, and the 4th chapter, which is differential equation, that is also very much based on the topic integration. Now let's first understand what is integration. Integration, another name for that is primitive, or we can say anti-derivatives. So now when I talk about anti-derivative over here, derivations, or you can say differentiation, you have seen in the previous videos also, and it's just the previous chapter. In this, we are going just opposite to that. So the way you used to do earlier, that earlier it will be dy by dx, here dx will come in multiplication to get the stuff. So if we are writing one particular value as fx as x cube, okay, so its integration of 3x square dx becomes x cube. The symbol used is this. Along with that, we also write fx becomes your integrand, and then we write dx next to it, which is basically the variable for integration. So in case of integration, we'll use this symbol like integration of 4x cubed dx, and the answer is coming as x to the power of 4 plus c. Now how this answer comes, that we'll be discussing. There are various formulae for that which we'll be following to get the integration. One difficult thing over here with integration is that we are not having rules like uv. Definitely one rule will be there for uv, but that also is having with a lot of restrictions. Or we are not having something like u by v. So in most of the cases, we have to first simplify the question in such a manner that we'll be able to solve it. So first, let's have some standard functions formulae of integration. Let's have a look at that. So like d by dx of x to the power of n is nx to the power of n minus 1. And when we go with integral of x to the power dx is x to the power n plus 1 upon n plus 1 plus c. Now in all these questions, you must be seeing I'm talking about plus c. This c is known as the constant of integration. And why are we using this? ये भी मैं अभी आपको explain करती हूँ just after some time, after discussing all the formulae. So integration of 1 by x dx is log x plus c, because d by dx of log x is 1 by x. Then we have integration of a to the power of x dx is e to the power x by log a. डिफ्रेंसिएशन में जहां हम मल्टीप्लाई करते थे कांस्टेंट्स को, यहां हम डिवाइड करेंगे. Okay, e to the power of x, since log e becomes 1, this is the only function जिसमें differentiation and integration same होता है. So e to the power x का differentiation is also e to the power x and integration is also e to the power x. Then same thing if we are going with a linear equation like ax plus b. So we are dealing with linear equation in one variable. This will become ax plus b to the power of n plus 1 upon n plus 1, and this a which is there with a, x, this, the coefficient of x, will be divided over here. Again, I'm saying that differentiation may we used to multiply. In integration, just it's antiderivative, so we are dividing it over here. Similarly, integral of 1 upon ax plus b, so log ax plus b divided by a to the power px plus q, so a to the power px plus q upon log a multiplied by p. E to the power px plus q, same value divided by p. So these are the general basic formulae which will be applying in any kind of integration rule. Now there are certain basic rules which we follow, like if there are two different functions which are added in this form integration, finally we can calculate individual integration and add. So in the same manner, the division part is also there. We can do that. Individual, this subtract. Okay, not division, it is subtraction basically. The constant thing kfx, k will come out and then you'll get integral fx as the answer. So these are the basic rules. First result you've just seen, integral fx dx is f capital Fx dx plus c, and if it is ax plus b, then according to the formula whatever answer will be there, that upon a plus c. So before moving to some of the solved examples, क्योंकि एक दो ही करेंगे because we'll be doing more questions over here. Understanding will only come when you see the questions here. Just think again one thing, that simplify the question to the solvable state and then apply the formula. So like let's see, the question is evaluate, this is one example, x cube 2 minus 3 by x whole square. Now when we take this example, we can't use a formula like x cube multiplied by this. So we have to get it into one form. So we'll expand the second part, 2 minus 3 by x whole square, by our identity a minus b whole square is a square minus 2ab plus b square. So when you open this identity, then multiply it with x cube, and then you will come across a simple equation which can be now our integrand, and now we will integrate that thing. So 4x cube has come, so it is 4 x to the power 3 plus 1 by 4 minus 12x square, so x 2 plus 1 is 3 by 3, 9x which is 9x square by 2 plus c. This is how we come to the answer. Okay, if the question is in the form say e to the power of a log x. Now there is a rule again which I want to tell you people, if you are not aware of that. E to the power of log x actually equals to x. Okay, this is one general formula which you should know. It's not only for the integration chapter or derivation chapter, it's a general formula. So e to the power of log x, definitely we're talking about the natural log base e. So first log x will convert it to x to the power a, and this answer becomes x to the power a. This will become a to the power of x using this formula, and then we'll apply the formula. So apply this as x to the power of n. Instead of n we have got a. So x to the power a plus 1 upon a plus 1 plus a to the power x by log a plus c. So this is the first kind of question which will come across. The second kind of question which we are going to see is using the method of substitution. Now the problem here is, if we are changing the variable of a question by assuming something else or using substitution, we have to in fact change the value of dx also. Means the variable of integration also needs to be changed. So if we are assuming something as t is equal to say ax square plus bx plus c, then we have to convert dx as dt. And here the complication comes. So if we are assuming x as phi t, then the function will get converted to the d part with dt in picture. So we'll be learning this part also. Now I'll make you do some questions so that you'll get a better idea how are we doing, and as I was telling earlier also, I'll be telling you why are we using C, the constant of integration here. So we are starting the questions from exercise 5.1. Let's take the first question for example. So when we take this question, the question states integral minus 2 upon root 5x minus 4 minus root 5x minus 2 dx. Now, one habit which I want you all to have from the starting itself is, whenever you are calculating integration, write I is equal to that question. Capital I is used to find out the integration. Now, this particular formula, we do have something for root, but you don't have something for root a minus root b. So first we'll simplify that and get these root terms in the numerator. And how are we going to do this? By rationalizing. So take minus 2 out. This root 5x minus 4 plus root 5x minus 2. Rationalizing factor always is the same number with a different sign. And here root 5x minus 4 plus root 5x minus 2. Why do we have this different sign? So that we get the formula of a square minus b square and the square root disappears. So this is now minus 2, I'm taking it out right now, integral root 5x minus 4 plus root 5x minus 2, and denominator will now become root 5x minus 4 whole square and root 5x minus 2 whole square. Whole square means square root will now get eliminated. So this is 5x minus 4 minus of 5x minus 2. Please don't try to do it directly, because sometimes when you do it directly, you forget to change the sign and that can create problem. So now here minus 2, numerator is again the same. Even though you have to write the step one more time, it's better to be cautious rather than making careless error. So 5x minus 4 minus 5x plus 2 dx. Now when you see this part, 5x and 5x will get cancelled. And minus 4 plus 2 is actually minus 2. So your final answer becomes minus 2 upon minus 2 integral is equal to root 5x minus 4 plus 5x minus 2 dx. Now still, it's not that we have done the integration till this stage. We have still just made it comfortable for you so that now we can integrate this particular integrand. This thing will get cancelled and then we'll start with the next part. So I'm erasing the first part to write the final answer over there. I hope you people are now clear that you have to do rationalization here. Now root 5x minus 4 is actually 5x minus 4 to the power of half. So according to the first formula, it will become half plus 1 upon half plus 1. But since the format is ax minus b, 1 upon a comes as denominator, and here a is 5. Same in the second one, plus 5x minus 2 to the power of half plus 1 upon half plus 1, and then again 1 by 5 plus c. As soon as we apply the integration formula, plus c should come into the picture. So now this is your final answer. So 5x minus 4 to the power of 3 by 2. This again becomes 3 by 2. So 3, 2 will come in the up part, 1 by 5 plus 5x minus 2 to the power of 3 by 2 upon 3, 2 will go up into 1 by 5 plus c. You can take this 2 by 15 common, which is there in both of them. So you can take 2 by 15 out. The other part is now 5x minus 4, 3 by 2 plus 5x minus 2 to the power 3 by 2 plus C. This is your final answer for the question. Okay? Now, the next one, before moving to the next question, I'm giving you the concept of having that constant of integration, C. So as I said, integration is actually opposite of derivative. So let's take one function fx and see its derivative. Now fx is, say, 4x cube plus 3x plus 2. The f dash x of this will become 12x square plus 3. Now, since it is antiderivative, integral of f dash x dx should be equal to fx. Let's put it 12x square plus 3 dx. Now this becomes 12x cubed by 3 using the first formula, so by n plus 1 by n plus 1, plus 3, since there is no variable, it is x to the power 0. So again x to the power 0 plus 1 is x, and this is coming as 4x cubed plus 3x. But what about the constant 2 which was there in the question? We are not able to get that value in the final answer because of the lack of its presence in f dash x. So for this thing, we actually use a value, say C, constant of integration. So it means that in the original question, there should be a constant. Now that constant can be 0 also, but one constant can be there. That's why we always write the thing C. I hope it's clear. Now we are moving to another question which is having that constant. From the same exercise, let's take question number 7. So if f dash x is equal to 4x cubed minus 3x square plus 2x plus k, they've already given f0 is 1, f1 is 4. You have to find out fx. Using the same antiderivative concept, we'll be going with this. So first thing, fx actually will be equal to integration of f dash x dx. So when we calculate this, it's 4x cubed minus 3x square plus 2x plus k dx. Let's quickly integrate it. So 4x cubed becomes 4x to the power 4 by 4 minus 3x to the power 2 plus 1 is 3 by 3 plus 2 x square by 2 plus kx plus c. Don't forget, don't think already k use हो रहा है तो c की जरूरत नहीं है. This is your fx. Now the problem arises कि what is the value of k and what is the value of c. So we've got two values here. f0 is given. So we'll put that when everything is 0, you are just left with c, and f0 is given as 1. So we get the first value, that c is 1. For the second one, f1 is given. So at x, every position of x will be replacing it with 1. So we'll get 1 to the power 4, 1, minus 1, plus 1, plus k, and plus c, which was already 1. So this value is equal to 4, that's given to you. So we are getting 2 plus k, and therefore k will be equal to 2. Now once you get the value of k and 1, fx can be finally written as, the value will be x to the power of 4 minus x cube plus x square plus 2x plus 1. So this is your final statement, taking care of all the missing variables also. After this, we are moving to another kind of questions where substitution will come into the picture. So it is the second exercise which we are going to see, and substituting the things. Now in this chapter, you will be seeing a lot of examples are given in your textbook, which I advise you to follow. Please solve them please solve the rest of the questions also, because then only it will give a good grip on the subject. Let's see the question over here. Again, from this exercise 5.2, I'm taking one question, question number 2. Integral x cube by under root 1 plus x to the power 4 dx. Now there is no rule like u upon v over here, so we have to deal with some other form, let's say substitution here. Now the question arises, which thing exactly you need to substitute? In most of the cases, denominator substitute होता है. In most of the cases, जिन चीजों में आपके powers या कुछ आ रहा है, root or these things, that need to be substituted. So here let t is equal to 1 plus x to the power of 4. So dt by dx is 4x cube. Here we are simply differentiating. So dt upon 4 is x cube dx. Now this is a numerator which can be replaced by dt by 4. So your question I is now equal to integral 1 upon root t dt by 4. Now it has become very simple. So this will become 1 by 4. 4 is constant over here. T to the power of minus 1 by 2 dt. Applying the first formula, we'll get t to the power of minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 plus c, which will result as 1 by 4 root t, because this is t to the power of half. Below it is 1 by 2, so 2 will go up plus c, and by substituting we get 2 by 4 under root 1 plus x to the power 4 plus c. This you can cancel as 1 by 2. This is your final answer. So this is how substitution works. Another question let me take for substitution. It is a log question, because log is one area where our assumption is not always the denominator. Here in this question definitely it is, but since log x का d by dx आपको 1 by x मिलता है, so in that case जो आपका dt आएगा उसके लिए x आपको denominator में ही चाहिए. So the question, let's see, 6th one is 1 upon x log x dx. So let, and I, don't forget to write this I, let log x is equal to t. So 1 by x is dt by dx, and therefore dt is equal to dx by x. So now your question become very simple here. So it is, because dx by x completely will go as dt, so 1 upon t dt, which is log of t plus c, and then resubstitute, so log of log x plus c. That is your final answer. Clear? So this is the way we use when we actually do the substitution part. Okay. Now the next form of the question is another form in which we have a question in a specific integrable form, like a e to the power x plus b upon c e to the power x plus d. Similar यहाँ पे भी हम लोग substitution ही करते हैं. We are not going with anything else, basic substitution. But एक थोड़ा सा hint लेते हैं before substitution, that if the question is in the form of some numerator upon denominator in the terms of e to the power x, then your numerator becomes a multiplied by denominator plus b multiplied by d by dx of denominator. Okay. Now this a and b, this is what we have to actually calculate to come to the answer. Okay. And once we get the a and b, we can simplify the question in a basic format. So let's see 5.31 question. Question number, say, 3. So the question suggests 3e to the power of x plus 4 upon 2e to the power x minus 8 dx. Now the numerator is 3e to the power x plus 4 as the formula suggests. 3e to the power x plus 4 is equal to a, the denominator, plus b, the d by dx of denominator. Now d by dx of this denominator is 2e to the power of x, because minus 8 is a constant, it won't be there in the question. So when you open, you will get 2a e to the power of x minus 8a plus 2b e to the power of x is equal to 3e to the power x plus 4. Now here we'll do direct comparison. So there are two terms of e to the power x and one term which is a constant. So 4 is equal to minus 8a, and therefore we get the value of a, which is minus 1 by 2. For b, we'll use this value of a. 3 is equal to 2a plus 2b. So instead of a over here, we are going to put minus 1 by 2. So 3 is equal to 2 into minus 1 by 2 plus 2b. This gets cancelled. We'll go to the other side. 3 plus 1 by 2 is b, and therefore b is now 2. So the question is now simplified in this manner. Now we can write the question as I is equal to I in the starting also. Instead of numerator, we'll use this whole terminology. So a ki jagah pe we are putting minus 1 by 2, 2e to the power x minus 8 upon 2e to the power x minus 8 plus, instead of b it is 2e to the power x upon 2e to the power x minus 8 dx. This is your question. Fine. Now here you can see numerator to seedhe cancel ho gaya aapke denominator se. This is the reason we were doing all this thing. Second case में इसका ये d by dx है. Now there is a rule as such that if we have, इसको आप डायरेक्ट फॉर्मूले की तरह भी ये रूल ले सकते हो, that integration of f dash x upon fx dx is actually log of fx plus c. So when you apply this in the question, आप side में ये formula definitely लिख देना, so that the teacher knows that you are applying this particular formula. So when I'm applying this formula here, the question actually goes as minus 1 by 2x, because ये term cancel हो गया है, and here it is 2 log of the denominator, 2e to the power x minus 8 plus c. And this is what is your final answer. Side में ये formula short लिखना है आपको. So this is another kind of question which will come across in differentiation. Before I move to the next one, let's discuss the formulae one more time, because a new set of formula is coming into picture. The next set of formulae basically are these four specific formulae, where it is 1 upon x square minus a square integration. It will come as 1 upon 2a log x minus a by x plus a. These formulae are taken without any theorem proving. So you just have to learn the formula part. Then a square minus x square only changes. Numerator will become a plus x, denominator will be a minus x. Under root x square plus a square, it is log x plus root x square plus a square. And root x square minus a square will be x plus root x square minus a square. So while learning, understand the relationship between the things, it will become easier for you to learn the formula. So these formulae will be used either directly, or you will be actually dealing with converting the question in the desired format and applying it. So let's see the first part over here, which is dealing with root 9x square plus 25. But the formula is not of this form. When you see the formula, it is under root x square plus a square. So we'll take this 9 out of the square root. And if 9 goes out of the square root, it will come as 3 because root 9 is actually 3. So when you take 1 by 3 out, now you are left with x square and this is 25 by 9. I'm writing one intermediate step for your understanding over here. 1 upon 9 out. This is x square plus 25 by 9 and dx. So this intermediate step helps you to understand the thing. Okay. So once you get this particular thing, now this 9 will come out as 1 by 3. This is x square. 25 by 9 now will be written as 5 by 3 whole square. Okay. So once you come to 5 by 3 whole square, then you can directly apply the formula root x square plus a square, and your next step will be your answer. That it's 1 by 3 log under root x plus under root x square plus 5 by 3 whole square plus c. So these questions are not very lengthy, but you need to understand the formula base. Another one in this same manner is applying or changing the formula in the suitable form. Here also question can be converted to the same formula, but they're not directly given in the formula format. So let's see, the question is 2x square plus x minus 1. So when we talk about 2x square plus x minus 1, here, this is not in the given format, that is x square plus 1 or x square plus minus a square. So first we'll take 2 common, we'll make it 2x square plus half x minus 1 by 2. Now here the formula which we are using is completing the square method. Now in completing the square method, first number has to be a perfect square. For the second one, whatever you get, do half of that. So if we are having 1 by 2 over here, we'll do half of 1 by 2, which is 1 by 4. And add its square and subtract its square. So when we do this part, you can see that 1 by 16 will be added and 1 by 16 will be subtracted. Why are we doing both the steps? So that we are not changing the question at all. Now once we get this value and then minus 1 by 2 was there in the question, this first part becomes x plus 1 by 4 ka whole square. And the second part you will subtract and calculate, like addition of minus 1 by 16 minus 1 by 2. You will get 9 by 16, which can be taken as 3 by 4 whole square. So now it is of the format which you require. So once it is in this format, 1 by 2 is this, 1 upon 2a. Your a is 3 by 4, which will come over here. Log x minus a upon x plus a. So instead of x, now we are using the full term x plus 1 by 4 minus 3 by 4, x plus 1 by 4 plus 3 by 4. And then we solve it. So you will come across x minus 1 by 2 upon x plus 1. You can also write it as 2x minus 1, 2x plus 2 as the final answer. So in this question, what we did was we converted the question in the form of the given format of the formula. One more very important thing which you have to keep into notice when we are doing the question. In case, if the numerator is of a higher power, in case, then the first step will be to divide the numerator by denominator to simplify it in the form of ax plus b. So that also we'll see the question in this way. For the same, let's do the question from exercise 5.4. Let's take a question number 3 over here. So when we are doing this question, see the question 3. The question states, I आपको निकालना है 1 upon 4x square minus 20x plus 17 dx. Now this is not of the format which we want, so we will convert it to the format. तो सबसे पहले तो हमें x square को separate करना है, तो ये 4 बाहर लाना पड़ेगा. 1 by 4 integral 1 upon, this is x square. Now 20 से 4 divide होगा, तो it is 5x plus 17 by 4 dx. Okay. As soon as this comes out, we are left with now completing the square. सो टू कंप्लीट द स्क्वायर, अभी मैंने आपको बताया था ये जो x वाला टर्म होगा उसके हाफ के स्क्वायर को आप ऐड करोगे एंड सब्ट्रैक्ट करोगे। तो यहाँ पे इट इज -5x, लेट्स ऐड दिस फर्स्ट, तो इट इज 25/4, subtracted -25/4 plus 17/4, which is already there in the question. So now this part becomes your 1 upon x minus 5/2 का whole square. Please see to it why it is minus, क्योंकि second वाला term आपका -2ab का term है। यहाँ वाला part when you solve, it is 8/4 which is 2 dx. You can write it as 8/4 also first and then come to 2. Now when you see first part is square but second part हमें as a perfect square नहीं मिल रहा है, so don't get scared, उसको हम perfect square में convert कर लेंगे as x minus 5/2 whole square minus √2 square. Now this is the question of the given format. अब हम directly formula लगा रहे हैं, ये 1/4 आगे है, formula states 1 upon 2a, तो 2a is √2 log x minus a upon x plus a. तो x minus a is going to be x minus 5/2 minus √2 whole divided by x minus 5/2 plus √2 plus c, and in the final answer you'll be writing 1/8 √2 log, जब आप इसका LCM ले रहे हो तो ये 2 will get cancelled later on, so you are left with 2x minus 5 minus 2 √2 upon 2x minus 5 plus 2 √2. So this is your final answer format. Okay? एक क्वेश्चन और लेते हैं जो स्क्वायर रूट के फॉर्म में है, which is not exactly this one. Let's take a simple question over here, say 3x square minus 5 here. So 10th question it is, I is equal to under root 1 upon root 3x square minus 5 dx. Now why did I choose this? Because जब आप 3 का square root ले रहे हो तो एक fixed answer नहीं आता है, you have to write in the terms of root. So here first I'm going to take this 1/√3 out of this. What I'm left with is under root x square minus 5/3 dx. Now we have to write it into the given format, which is root x square minus a square. So again 5/3 perfect square नहीं है, so इसको convert करने के लिए हम simply इसको root 5/√3 करके whole square कर देंगे. So this is what we get over here. Now this is the given format. The answer comprises as 1/√3 log x plus under root x square, that is this, minus root 5/√3 whole square plus c. इस क्वेश्चन को थोड़ा सा और सिंप्लीफाई कर सकते हैं. This is 1/√3 over here log, इस पार्ट को now we'll solve. तो this is going to be under root x square minus 5/3 plus c. Now when you take this out, 1/√3 log, ये 3 यहाँ पे आ जाएगा x plus under root 3x square minus 5 upon root 3 plus c, which can be simplified 1/√3 over here log x root 3 plus root 3x square minus 5 upon root 3 plus c. Now why did I show this? Because if you see the answer in the books, textbooks, ये root 3 बाद में नहीं लिखा रहेगा. So if you remember the log rules, log m upon n can be written as log m minus log n, and when you separate this log root 3, this is a constant only. So we write the final answer as 1 by root 3 log x root 3 plus root 3x square minus 5 plus c1 or c dash. Okay, because now this log root 3 also has become a part of the constant. So this is another kind of question which we come across, and now we'll come to something which is very, very important. Most of the time you get a question based on this. This is a new concept itself. It's theorem 5 here. That is known as integration by parts. Or you can see this is the UV formula for integration. But certain restrictions, certain constraints are there. So when we write the formula integral UV dx, it comes as U integral of V dx minus integral, take a big bracket, this V dx dot du dx to the power of dx. So formula seems big. 2-4 क्वेश्चन के बाद आपको easily समझ में आने लगेगा and you'll be able to solve it properly. But here, UV cannot be any terms like this. It can't be like 3 into 2 is 2 into 3. यहाँ पे हमारी एक preference होगी that what should be your U, what should be your V. In general जो rule है उसको हम लोग या तो लियाटे और आइलेट से लेते हैं, but because आपके पोर्शन में ट्रिगो नहीं है, तो यहाँ पे जो आपका रूल आएगा that is LAE, which is actually equal to L for logarithmic function, E is basically for exponential, and A is the algebraic function. So in case if you have logarithmic function along with algebra or E, logarithmic function will be given the preference. Similarly, अगर आपका algebra and exponential है, then algebra becomes your U. So using this technique, we'll be able to solve questions here. So let's see one question of the type by parts to get the answer here. Applying the question in the by parts thing. Say the question over here is integral x log x dx. Now there are two terms, log x and x. So first we have to take log x as u because the rule is LAE, and x will become your v. So when we apply integration by parts, it becomes log x integral v dx, which is x dx, minus integral d by dx of log x, put a big bracket over here, then the integral of x dx, and then dx again. So this thing will become log x integral x dx minus integral of d by dx of log x becomes 1 by x. So we'll put 1 by x. Integral of x is x square by 2 and then dx. Now we will integrate finally. So this becomes integral of x dx is x square by 2 log x minus, now यहाँ पे ये एक x cancel हो गया तो we are left with x by 2. So it is 1 upon 2 multiplied by x square by 2 plus c. Or the final answer will be x square by 2 log x minus x square by 4 plus c. So this is how we'll be applying the UV formula. We can also see one question over here where we are not only applying UV but also substitution. So that is question number 4. In this, it's x cube e to the power x square dx. So x square को हम लोग ले रहे हैं, let x square is equal to t. So 2x dx is dt. Now the question becomes integral x cube can be written as x square into x into e to the power x square dx. So x dx will be your dt by 2. So 1 upon 2 t e to the power of t dt. Now the format is basically of uv. Between algebraic, because t is considered as algebraic, and e to the power of t, your preference is given to t. So it will become half out, take a big bracket, t integral of e to the power t dt minus integration of d by dt of t integral of e to the power t dt and then final integral dt and then bracket close. So this is half. This part becomes t e to the power of t because integral of e to the power of t is e to the power t minus integral d by dt of t is 1 and this part is again e to the power t dt. So it becomes e to the power of t dt. Because 1 multiplied by that होगा तो 1 का effect हम लोग finish कर रहे हैं and then your final answer will become minus half t e to the power t plus half e to the power of t plus c. And don't write the answer in terms of t because question was there in terms of x square. तो आप last step पे ये हर एक t को replace करोगे with x square in the last line. So this is how we apply the UV formula for finding out integration. Another method which is there is if the question is of the format e to the power x fx plus f dash x, directly we can get the final answer as e to the power of x fx plus c. Now again you must be noticing so many different methods, so many different formulae, and that is the reason the chapter is considered tough. So please practice all of them one by one. At the end I'll give a compiled formula list also for you. So this one is, let's say question number 5 over here. I is equal to integral e to the power x 1 by x minus 1 by x square dx. Please write specifically let fx is equal to 1 by x. Therefore, f dash x becomes minus 1 by x square. And then applying this formula, your I will be e to the power x fx plus c, which is e to the power x into 1 by x plus c. This will be your final answer. So till now we have done various kinds of different formulae which we applied, and one more part is left which is known as integration by partial fraction. Now the last part of this particular chapter is dealing with partial form. Again, the rational form gets converted to the partial form where you'll be getting 2 or 3 variables and we calculate the variable to get the final answer. So a table is there to tell you that which should be the format over here. Like you can see, px plus minus q upon x minus a, x minus b. This part actually decides कि आपका table का format क्या होगा. If there are 2 similar simple terms, linear terms, then it is a upon x minus a plus b upon x minus b. If there are 3 of them, then a plus b plus c. If there is x minus a whole square, then it is a upon x minus a plus b upon x minus a whole square. Similarly, if there is one more b, तो x minus b. Cube को भी उसी तरीके से treat करेंगे. And the last one is px square plus qx plus r, and below we are having something like ax square plus minus bx plus minus c, which is non-factorizable. So then the numerator will have bx plus c. Rest of them, the numerators were simply a, b, c, d. So now first we'll convert it into this form. Once we get it into this form, then the question becomes very easy and then we can solve it with the normal formula. So let's take one question of exercise 5.6 over here. Say question number 1. So I is equal to integral 2x plus 1 upon x plus 1 upon x minus 2 dx. Okay. So now when we are having this particular thing, first we'll write this question in the partial fraction term. So we divide it into partial fraction a upon x plus 1 plus b upon x minus 2. So this becomes now a into x minus 2. Numerator को ही हमें compare करना है. Upon 2x plus 1 is equal to this. Denominator दोनों में same हो जाएगा. So let's compare now the value of a to get the value of a and b. There are two ways to do it. One is आप इसको simultaneous equation से करो, but we'll not do it by simultaneous equation. We are smart people, तो हम इसको थोड़ा सा smart way में करते हैं. Let's assume the value of x as something so that one variable becomes 0. तो first case में let x is equal to 2. Therefore 4 plus 1, क्योंकि x is equal to 2 हमें left hand side में भी डालना है, becomes a into 0 plus 3b. So 5 by 3 is your b. Similarly, let x is equal to minus 1. So this becomes minus 2 plus 1, which is equal to a. Now this is minus 1 minus 2, and b will become 0. So you are left with minus 1 upon minus 3 to get as a, which is 1 by 3. Now once you have the values of this, now we'll put it into the formula this to get the answer. So the same integration आप नीचे लिखोगे, इसको चेंज नहीं करोगे. This integration now is equal to a की जगह पे हम लिख देंगे जो हमने a को कैलकुलेट किया है, which is 1 by 3, and b की जगह पे हम लिख रहे हैं what we have calculated as b, that is 5 by 3 and dx. This is the question format now for us, and इसको simply integrate करना है, which will become 1 by 3 log x plus 1 plus 5 by 3 log x minus 2 plus c. आप आंसर इस फॉर्मेट में भी छोड़ सकते हो, या फिर आप log m plus log n का रूल log mn भी अप्लाई कर सकते हो. So this was the last part of the chapter which was dealing with partial fraction. Now for all these questions, I definitely recommend you to do more practice because integration comes with practice. Formula भी आपको धीरे धीरे by heart हो जाएगा अगर आप ज़्यादा questions practice करोगे. And I'll see you with the next part of the chapter, that is definite integral. That also helps you in understanding this chapter more. So till then, study hard. Bye bye.